What did the circle say to the tangent line? Stop touching me. You get it? Touches at one point. So this part of the notes, we're primarily focused on tangents. And tangents are pretty awesome. They are always, remember, we already learned that they're always perpendicular to the radius at the point of tangency. Now, if you have two tangents, from different parts of the circle, so you can see this is tangent to point B, that's tangent to point C. You can ignore this W stuff because I'm using this picture for an example later. But if both those lines meet at another point D, what's cool is these two segments will always be congruent. BD will be congruent to CD. And I can prove it to you. So let's see. First of all, AB is congruent to AC. Why? Well, all radii for the same circle are congruent. And I know that AD is congruent to AD. I just connected the center to that external point. And that's by reflexive property of congruence. Something is always congruent to itself. Now remember that these are right angles because tangent lines are perpendicular to the radius there. And since I have congruent hypotenuse here, hypoteni, and congruent legs there, I can say these two triangles are congruent by the hypotenuse leg theorem, which we learned in the fall. Now that I know the triangles are congruent, I can say that the sides are congruent by CPCTC, which is corresponding parts of congruent triangles are congruent. Now you'll notice I did that and I had no angles marked, nothing marked on this except for the fact that these two lines were tangent to the circle and they met at point D. So all tangents that share an external point are that segment from the circle to that point. Those segments are congruent. So let's go ahead and use the picture and actually work out the examples. So since we know that these two are congruent, I can actually find their length. I set the two lengths equal to each other. 4W plus 2 equals 6W minus 12. Subtract 4W from both sides, and then add 12 to both sides, and I get 2W is 14, which means W will be 7. Now that I know what W is, that's not what I asked for. I'm looking for BD. I can substitute it back in. And so now I get 4 times 7 plus 2, or 30. So both the tangent segments are 30 units long. Now, same problem. I know those two are 30. And if I give you the radius, you can actually find the length of AD. So we know that the two radii are congruent, and we said that they are 18 units. All right, I went ahead and filled in AD, and I drew in the right angle. Why did I do that? Well, that means I could use Pythagorean theorem to find AD because AD is the hypotenuse. So I'm substituting in 18 squared, which is a leg, and 30, which is a leg. Squaring that equals x squared. 324 plus 900 is x squared, or 1224 is x squared. And this is so close to a perfect square, it's just one off. So when I take the square root of both sides, I get 34.99. So that would be the length of AD. Now, circles are congruent if they have congruent radii. So if I know this length is, say, 20, then CD has to be length 20. Otherwise, the circles are different sizes. And I can use that to find missing values. So here, we're saying both of these circles are congruent, and I want to find the radii. So I just set them equal to each other. And I solve for x, subtracting x from both sides. I get x minus 4 equals 4. Add 4 to both sides, and I get x equals 8. To find the radius, I substitute back in. 8 plus 4 is 12. I don't have to do it for AB because both have the same length. Both of these radii are equal to 12. Now, one other thing you need to know about are pairs of circles that are concentric or tangent. So concentric circles are coplanar. That means they're not like turned out of the paper in different ways. They're in the same sheet of paper, and they share the same center, which can kind of make it confusing for naming. Tangent circles are two circles that are coplanar that share exactly one point. They touch at one point, all right? So we've got tangent circles and concentric circles. Concentric means share center, and then tangent was the touching. So if I was looking at concentric, two circles here that share the same center, it's this circle right here with the center at A, and this larger circle here with the center at A, which means they're both circle A. And at this moment, I don't have a different way to name that, so that is kind of giving me the heebie-jeebies. All right, now I have two circles that are tangent externally. They have to be touching each other, but not inside of each other. And that would be circle A, the large circle, and circle C. Both of those are tangent externally. Now I need two circles that are tangent touching internally. So one is inside of the other, and they touch at one point. That would be circle C here and circle G. Finally, I can say that circle A, I mean the little one there, and circle C are congruent because the radii are marked as congruent. They are not tangent, and they're not concentric. They're just congruent. So for reflection, what is the relationship between two tangents to a circle that have a common endpoint? And I should say outside of the circle. You should remember that the tangents will always be congruent. Remember how we did the little hypotenuse leg proof for that. Are all segments that intersect a circle in only one point tangent to that circle? Well, no. If I said lines, then the answer would be yes. Can you think of a segment that intersects a circle in only one point but isn't necessarily tangent? To be tangent, it must also make a 90-degree angle with the radius. Explain what it means when two circles are tangent. Remember, they can be tangent internally or tangent externally. And then finally, what are some characteristics of tangents to circles? Hopefully you realize one of the big things is that they are always perpendicular to the radius at the point of tangency. So we'll be dealing a lot with right triangles. The other cool thing is when you have two of them that are tangent to a circle and they have the same external endpoint, the segments from the endpoint to the point of tangency will be congruent.